Hello everyone. In this video, we are going to see the chef like good sequences question that came in CodeChef October lunchtime. Let's see the question. Chef calls a sequence good if it does not contain any two adjacent identical elements. Now, what this line means? Suppose if there is a sequence 1, 2, 3, 4. So this sequence is good when there is no two adjacent identical. Suppose if it is 1, 1, then they are not good. This sequence will be not good. 1, 1, 3, 4 will be not good. But 1, 3, 4 will be good. 1, 4 will be good. Suppose and 1, 2, 3, 4 is this will be good because there is no adjacent identical element. But 1, 2, 2, 4 will not be good. And similarly, 1, 2, 4 will be good. Okay. So this is what the good sequence means here. Now, initially chef has a sequence A1 to AN. He likes to change the sequence every now and then. You should process Q queries. In each query, chef chooses an index X and changes the X element of the sequence to Y. After each query, can you find the length of longest good subsequence of the current sequence? So what we will get in each query, there will be Q queries, and each query, in each query element at index X is, suppose if an array of X is there, it will be changed to Y. This is what the query will do. And after each query, after performing this each query, what we want the length of longest good subsequence. You can say longest good subsequence. What is the length of longest good subsequence? This is what the question is asking to us. And this was the explanation of the question. Now let's see the approach to solve this question. Okay. Here I have written all the important pointers that will be used in this question. Now let's see the some example to better understand it. Suppose if we have been given sequence 5 and it is 1, 1, 2, 4, 3. Okay, this is the sequence suppose. And now in the first query, we have been said the second index will be changed to 3. Okay, second index will be changed to 3. So we will pick this second index. This is first index, this second, this is third, this is fourth, this is fifth. Okay, we pick this a of 2. I'm taking one index base. I'm not taking 0 base index in this example. So a of 2 will be 1 currently. Now after performing this query, a of 2 is equal to 3. This is what the query will do. Now we have to look the longest good subsequence. What was the before performing this query? What was the longest good subsequence? Let's calculate that. Okay, if it is 1, 1, 2, 4, 3. See, if is 1 equal to 1, yes it is. So now this sequence cannot be good. This sequence cannot be good. So we will not count this one. So we write 1, 2. After 1, we write 2 because it is not equal to 1. Okay. Now after 2, we write 4 because it is not equal to 4. After 4, we are write 3. So after this is not equal to 4. No two additions are identical here. So this is good subsequence. And what is the count for this? The count is 4. So this is what they are saying that good subsequence should be. So before applying this query, the good subsequence was 4. Now after applying, what is the array? What is the sequence you can say? 1, 3, 2, 4, 3. Is 1 equal to 3? No, we will count 1. We will count 2, sorry, because there are 2 elements in the subsequence. Okay. Is 3 equal to 2? Yes, it is equal to 2. And this has been counted, so it will be also 1 plus 1, you can say. Okay, for better understanding, do not confuse it. You can get confused by 2 and 1. Let's count like this. After 1, is it equal to 1? No, it is not. So it will be included. This will be included in the subsequence, and this will be included. After 3, is 2 equal to 3? No, it is not. So it will be also included. 2 after 4 will be included because it is not equal. 4 after 3 will be included because it is not equal to adjacent element. 3 is present in this sequence, but we want good subsequences, those which are not adjacent same. If this 3 was present at the place of 2, then this sequence cannot be good. Suppose if this sequence is 1, 3, 3, 4, 3, then it is not good because 3 and 3 are coming together. Okay, but 1, 3, 2, 4, 3 had no two adjacents are same, so it can be. And what's the count? 1, 2, 3, 4, 5. So 5. So here you can say it is pretty direct question. What we can do to find this count? We can only run a loop. What? From I is equal to, you can say 0 to n. and we can check that, or you can say I is equal to 1. It will be more important, more better. Okay. And if we check that if a of I is not equal to a of I minus 1, then we will increase the count. We will simply increase the count. Else we will do nothing. Else we can do nothing. This is what the we can do. And initially we can take c is equal to 1. So here if we apply in this form, this loop here for this subsequence, let's see it here. If suppose I'm taking 0 base indexing now, 3 4, yeah, I'm starting from 1. Is 1 equal to a of I equals to a minus 1? No, it is not. So we will increase. See, initially c is equal to 1, because there will be one sequence which is good. Of course, if I take only 1, it is good. If I take only 3, it is good. So c will be always equal to 1, you can say. Okay. So initially c is equal to 1. Now is 3 equal to 1? No. So I will increase c. C is equal to 2 now. Is 2 equals to 3? No, it is not. So I will increase c is equal to 3. Is 4 equal to 2? No, c is equal to 4. 3 equals to 4? No, c is equal to 5. So this is what it is giving us the count. This loop is correct. It is giving us the count. And for each query, what we have to do? We will perform another loop. From you can say that j is equal to 0 to j is equal to q. Okay, j less than q, sorry. And we will increase this j. And in each query, what we can do? We can perform our operation. Perform operation that change a of x minus 1 to y. This is what we can do. This is what we can do. But what will be the time complexity here? The time complexity will be your O of q into n. And as we can say in the constraint, q is equal to 10 per, q can go till 10 power 5, and n is also equal to 10 power 5. So in total, they will make 10 power 10. Okay, which will give us TLE, which will give us time limit exceed. The first test case will be passed, but the second test case will be not passed. And after each query, we will print also C. We will print C. It will take O of one time only, but after each query, we have to print this C. So this is what the question is saying. This is what the question is asking to us. Can we perform the query, and after performing the query, we can get in the O of n time complexity or O of q time complexity. That is 10 to the power 5, only 10 to the power 5 times. This is what the question is saying. It will pass your first subtask. The first subtask will be passed by this pseudocode. Now, to optimize it, what we can do? If we to optimize, we have to see some more cases. Let's see some more cases. Suppose if the sequence is, if the it is 7, it is 1, 4, 5, 7, 3, 1 and 2. Okay. Now query, first query came, and in the first query I am changing the third element to 4. Okay. In second in the second query I am changing the fourth element to 6. Okay. Let's perform this query. Before performing, what is the count? As you can see, there is no adjacent, so the count will be equal to 7. There is no adjacent here, so count will be equal to 7. Now, if I change this 1, 4, 4, 7, 3, 1, 2. Now, where the change can occur? Change can, here I have in one query I have changes this element only. So the change can occur only in these cases. If these now there is there any need to check the whole count again, the whole array again, you can say the whole sequence, is there any need to check the whole sequence again? I don't think so. Why? Because if there will be change, if there will be decrease or increase in the count, it will be matter of these three elements only. These three elements, that is the after where the after the x element and before the x element. So you can say that before performing before performing this query, answer was 7. After performing this query, what will be our answer? After performing this query, answer will be your 1, and this is equal, so we cannot take this sequence, so we will take 4, and after 4 we cannot take 4, so we will take 7, 3, 1, 2. So the count is 6. It is decreased by 1. So because it is equal to 1, this thing is equal to this a of 3 is equal to a of 2. So that's why that count has been decreased. So we can store what we can observe from it. what we can observe from it? Firstly, we can observe that we should store the initial count of longest good subsequence. Okay, and after storing the initial count of longest good subsequence, what we can do in each query, we should only look that is there any change in the adjacent of x. Now, how to simplify this thing? That is there any change? Is this line from this line? I mean that what was the status of the adjacent of that element? Suppose if it is x, then what if early before performing query is a of x is equal to a of x plus 1, or a of x is not equal to x plus 1. This is what I want to say before performing the query. And similarly, I want to check that is a of x is equal to a of x minus 1 before performing this query. And is a of x is not equal to minus 1, you can say. So if they are equal, then we do not need to do anything. If they are equal, then we cannot do anything, because the count will be not increased only. The count from beforehand will be not increased. But if they are not equal, then what we will do? We will decrease our count. We will decrease our count from initial count decrease, because we don't know that what will be the newer after performing the query. We don't know that what will be our next answer. So we will remove this count from our original. You can say original count. Okay. Now, if a of x is now after performing query, after query. Now, if a of x is equal to, not equal to, a of x plus 1, we will increase our count. And if a of x is not equal to a of x minus 1, then we will again increase it. So, and we will print our C. So this is what the question is saying. This is how we can do this question. We will firstly store our count, initially store our count. Okay, then we will loop from I is equal to 0 to q, you can say. And for each loop, what we will do, we will check that is a of x is equal to a of x plus 1. If it is then we can do nothing. We will simply continue, because there is no need to do, because the count will be not increased by default only. Okay, if a of x is not equal to x plus 1, let's understand it with the help of example. Suppose it is 4 5 3 2 1. Okay, now if 3 is not equal to, suppose x is equal to 3. Okay, if 3 is not equal to 5, 3 is not equal to 2, then here count must have been increased. Here c plus 1 and c plus 1 had been taken place. Okay, now we will remove this thing. Why? Because we don't know that after performing this query they will remain same or they will become different. Okay, so that's why I'm removing these things. I'm removing these count. Okay, and now after query, if after performing query, if they are not equal, if they are after performing the query they are not equal, then I will increase. And if it is not equal to x minus 1 also, then I will also increase, and then I will print the C. So this is how we can do this thing is in O of Q time, and this will be get accepted. Okay, so this is what the approach that we can use to solve this question in the given constraint time, and it will pass both the subtasks. Now let's see the implementation for this question. Okay, now let's see the implementation for this question. Here I'm taking the test case input, then I'm taking the input in N and Q, then I'm taking the input in sequence, and here only I'm counting the initial that I told you beforehand that we will store the count initially. Okay, that what was the count for the original subsequence that we got earlier. Okay, now I'm storing the each query in query array that will be called here in from, then I'm querying from 0 to q, and in x I'm storing the first element of query array 2D matrix, and then in y I'm storing the second element of the query matrix of ith element. Now the condition that I've told you beforehand, before applying this query, you can say that before applying query. Okay, what was the count? If it is equal to, if it is not equal to, then we will decrease the count. And why I am decreasing, I told you earlier. Okay, now if a of x is equal to y, then I am changing the query. Now after applying query, it is after applying query, you can say after applying query. If after applying query also, if it is not equal to a of x plus 1, we will increase it. And if it is not equal to a of x minus 1, we will increase it. And I'm also checking that is x minus 1 is greater than equal to 0 and x plus 1 is less than n. And if it is, then I will append it to my answer. The count I will append it to answer, and last I will print it. Let's submit it and check it whether it is giving us correct answer or not. So this was the question. Basically, this was the question of you can do very easily in the brute force manner. For second subtask, you have to think only little bit. You will solve for 1 to 2 test cases on your own. You can do the second test or subtask also. There is nothing much. You can say this is passing all the subtask, all the cases. So this was the implementation.